Okay, what this is going to be, hopefully, is the Chapter 6 review with me going through it. So the first question says, compute, complete the following table indicating whether the random variable is continuous or discrete. So flip a coin 3 times. X equals the total number of heads. Since that's a count, it would be discrete. Okay, the next one is the number of questions answered correctly on a randomly true false questions. So that would also be discrete because that's a count. The number of companies in the portfolio, that would also be a number. So that would be discrete. So these three are all discrete because they're counts. The next one is the exact average of a weight. So that's a measurement. So that'd be continuous. And the last one, the exact height of a woman in inches, that would also be continuous. These last two are measurements. So for that reason, they would be continuous. Okay. The next one is says a researcher collected data on the number of cars owned per household in Johnson City. Let the random variable X represent the number of cars owned per household in Johnson City. The table below gives probability distribution for X in the given table. Find probability of 2. So you can see 2 is missing. So the sum actually has to add up to 1. So what I would do for this one is, let me a little space here. This would have to be equal to 1 minus the sum of the rest. So I would just add up the other probabilities. So I'm going to type it out here. So if I actually do that calculation, I'll pull up the calculator and do it. So you can see I typed it there. So 1 minus, it would be the sum of all the other probabilities, because the total has to be 1. So if I've added that correctly, I get 0.35. So this should equal 0.35. So we'd put that in for 2. And then what is the probability of a household with fewer than 4 cars? So when we think about fewer than 4 cars, that would mean less than 4. So for this one, this would be the probability X is less than 4. So all I would do is add up the probabilities that make less than 4. So for that one, it would be, let me go down here. So I would add up the 0.04 plus the 0.24 plus the 0.35 we just calculated plus the 0.18. And if we do that, I'll do the calculator here. And we get 0.81. Okay. Find the expected number of cars owned by a household in Johnson City and interpret your result. So for that one, we're going to have to do a little bit of work. What I would suggest doing is go through, and the X will have to be your L1 column and the P of X will be your L2 column. And so for this, we're going to do the one var stats on L1 and L2. I just spelled that wrong, so that's what I'm pulling back here. So pull out the calculator here. I'm going to scroll down a little bit so I can see the table. And so we're going to press the stat key, go to edit, and under L1, we're going to put the 0, the 1, the 2, the 3, the 4, and the 5. Oh, somehow I ended up not being in there. So I've got to put it actually in the list for whatever reason. I that got out of there. So put those in. And once L1 is in there, we're going to go over and put L2, and all those corresponding probabilities will go into L2. So we'll start with the 0.04 and work our way down the list. Okay, just quick double check that I entered everything correctly. It looks good. Okay, then we're going to go to the stat option, go over to the calc menu, and L1 will be under list, frequency will be L2. We'll just have to run that. And so my X bar is 2.32. So when it says the expected number of cars, that means you're using the formula, your expected value form, which is the sum of X times P of X, which according to this was 2.32, I believe. Let's go check it again. Yep. And then it also wants you to interpret the sentence. So what I would say on average is, let's go here. Actually, down here. We expect a household to have 2.32 cars. Find the standard deviation. Well, we already have that. And if you look, it would be the 1.279. We'll just say 1.28. So my SX down here, we could say the standard deviation would be your SX, and that would be 1.29, I think we just said. Yep. And then would it be unusual for a family to have 0 cars? How do you know? Well, you could use the mu plus or minus 2 sigma for that. So that would translate to 2.32 plus or minus 2 times 1.29. So if we actually do that calculation, so here we go on the calculator. And I get minus 0.26 up to, we do the plus side, we get 4.9. And so what we would basically say for that is, since what I would generally say is, let's go back here. Since 0 cars is in this interval, it is not unusual for a family to have 0 cars in Johnson City. Okay, that would be that one. So again, that one was all about using the calculator and the one var stats feature. So then the next one, we have a probability distribution below. Gives the potential cost of routine maintenance and major repairs in the last 5 years. Find the expected cost of routine maintenance and major repairs in the first 5 years you own a new car, and interpret this value in a sentence. Find the standard deviation. So let's give ourselves a little bit of room here. So what we're going to have to do is the same thing we did before with the calculator. This will be your L1. Oh, it's not liking this. Oh. Okay, this will be L1. L1, this will be L2. And we'll do the same kind of thing we just did. So we'll go over here. I'll scroll down so we can see the data set. So I'm going to press the stat key, go over to calc. So I have to edit it first. So under edit, we're going to add the new data set. So it'll be a 0 and then 500. and then 1,000, and then 1,500, and then 2,000. And then we'll delete that last piece of data from the old data set, and we'll do the same thing over on the other side, and we'll go enter those probabilities. So this time we did not have to go find a missing probability. They were all given. And if you look, they should all be between 0 and 1, and they should add up to 1 when you add them all. So all I'm doing is entering my probabilities. You should be able to see that on the screen. So again, always double check that you entered the data correctly. And then we'll go to stat. We'll go over to one of our stats, and you'll notice that I'm going to have L1 and L2 again. Since I keep using L1 and L2, I don't have to change those. And so my mean, my X bar, which in this case is actually on the calc, it really is mu here. So it's the 505. And then they also wanted the standard deviation, which was 363.97. So my SX, or my sigma X, will be 363 point, I think I just said 97. Yeah, 0.97. And then the interpretation is the expected cost of repairing a car is $505. It's actually over 5 years, but it's close enough. Okay, so those would be those one. And I would just say when this is the variation in the cost of owning the car. Okay, and then we have a table here. So it says how many people are in the poll participated. There's a bunch of questions about probability. So I think what I would do is, it doesn't have the totals. So let's add those up so we have them, and that'll make answering all our questions a little bit easier. So what I would do, and it also says round answers to 3 decimal places. So actually what I think I'm going to do is move this whole question down to the next page so it's all on one page. And we'll get rid of those. You notice I'm actually using Word in the inking tools, which I never use this. I always use it on a PDF, and I use that program Drawboard. So this is a little bit of a new experience for me as well, but I thought this might be easier than Drawboard, so we thought we'd try it. So what I would do is go add up all those totals and just do that first. So the first column, let's add up those numbers. So the total for the first column is 57. Let's do the next column. So we get a 63 for that one. So it's a little labor intensive, but we gotta do it. So the next column, I get a 92. And then we're gonna have to do the rows as well. But let's do the last column. And so I get 73. So assuming I'm adding all these correctly. So those would be the column totals. Let's do the row totals now. So let's move this up. So we're going to have 29 plus 15 plus 30 plus 19. That'll be the first row. So we get 93 for that. And then the next row, we'll do the 17 and so on. So I get 100 for that one. And then finally the last row. And that's a 92. Okay, so then the thing I need to do next is get a grand total. So I either can add up all of the column totals or all of the row totals. Either way we'll do it. I'll do the columns since it's a little easier to see those. And so I get 285. And just to be on the safe side, if you add those row totals, you should get the same total. You can see I get the same total. Okay. Give myself a little bit of space here for each one of these. Let's go do them now. Okay, so the first one is how many people participated in this poll? That would be the grand total. So that would be the 285. And then if one person is chosen at random, what is the probability the person responded to romance? So we go to the romance column, and that would be a 63 out of 285. And we can get the decimal approximation in a minute. If a person is chosen at random, what is the probability the person is under 30 and said thriller? So we want to go to the under 30 and the and said thriller. So that would be the 19 out of the 285. And again, we can get the decimal version in a minute. If one person is chosen at random, what is the probability the person is over 45 years old or they said comedy? So over 45, there's 92 people there. And or they said comedy, there's 92 people there, but then we have to take away the overlap. So the people that are over 45 and said comedy, that 28, we've counted them in both counts of 92. They got counted in the column, they also got counted in the row. So all of that over 285. Okay, and so let's just quick do those. So let's see, so the 63 divided by the 285 would be the 0.221. So just about a 22% chance. And then the 19 divided by the 285, that would be a 0.066 repeating. And that's a 5 actually, 0.066 repeating. So I would say roughly 0.067. I think it said go to 3 places. And then the next one, we'd actually have to do the math first. So it'd be 92 plus 92 minus 28. So we're going to end up with 156 over 285. So this would be a 156 over 285. And then from there, we would just do that division. And so we get about 0.547, roughly 547. Since we're cutting off the decimal, we'll use approximate. Okay. And then the last part of this question said, if a person is under 30 years old is chosen, what is the probability they said action? Okay. So for this one, you're specifically focusing on the people that are under 30 years old. So you're only taking from those 93. So this is one of those problems. It's a little bit, it's a given one. I think it's from 5.4. So we'll just do it anyway, but it's probably they said action. So that would be 29 out of the 93. And again, we can go through and calculate that one. And so about 0.3118, so 0.3112. Yeah, so 312. Okay, and that would be that one. That one's just a little bit different because you're actually restricting yourself to being in that first row and not the total. Okay, so then the next one is for each of the following situations, indicate whether whether it's a binomial distribution is a reasonable probability model for the given variable X. Give your reasons for your case. Okay. So you observe whether each of the next 50 customers is store pay with cash or by some other method. So people tend to be independent. So let me get rid of this. So I would say it's 50 is the fixed trials. That people are independent. And they paid with cash or not. So that means it's 2 categories. And then finally, the probability of paying with cash should remain constant. So I would say that's binomial. Kind of satisfies the 4 conditions. You observe whether each of 35 students earns an A, B, or C a class. So for this one, you've got the fixed trials of the 35. The students are independent, but where you fail is the outcomes are not success and failure. There are 5 categories. And we're not literally talking about succeeding in the class, like passing or not passing. What we're really referring to is we don't have 2 categories. We would need to. So it basically fails that part of it. So it's not binomial. I don't even have to go to the last part of it. We could make this binomial if we classified the grades as getting an A or not, or something like that. So that would not be binomial, but you could take those outcomes and turn it into, like, if you get this grade, it's a success, and if you get this grade, it's a failure, and that would work. And then for this last one, this would have, it does not a fixed number of trials. So not binomial. It fails that thing right away. So I'm not even going to go on any farther. Okay, so that would be for that one. Again, you have to have those 4 conditions, that you have a fixed number of trials, independent events, 2 categories for all the outcomes, so success and failure, and then the probability of success remains constant throughout. Those are the 3 things. Okay, and now we have a big old problem over here. So let me, I'm going to give myself some room in between each one of these, so we can. Okay, let's try that. So 35% of residents of a certain city believe that taxes should be raised to pay for road repairs. A random sample of 20 residents is chosen. Determine each of the following probabilities for the sample of 20, round each to 4 decimal places. So right away, this is binomial. So that would be my P. This is my N. Because people are independent, the probability of success is 0.35, and either they want taxes to be raised or they don't. So find the mean and standard deviation. So the mean would be N times P. So for us, it would be 20 times 0.35. And then for the standard deviation, that would be the square root of NP1 minus P. So that would be the square root of 20.35, 1 minus 0.35. Okay, so let's do those calculations. Let me move this down a little bit. Okay, so let's do the calculation. So 20 times 0.35 would be 7. So we expect about 7. And then the standard deviation would be the square root I'm just plugging in that calculation, and I get 2.13. Okay, so then it also said interpret these values in a sentence. So easiest way is we expect 7 of the 20 to favor raising taxes with a standard deviation of 2.13. So that's kind of your give or take. What is the probability that exactly 7 of the residents believe that taxes should be raised for road repairs? So here's the probability X is equal to 7. So that would be a binom PDF because it's exact 20.35 comma comma 7. Okay, so then if we go actually do that, remember you do second vars, scroll down all the way to binom PDF, and my trials will be 20. My probability of success is 0.35, and my X is 7. And so we'll paste, and I get 0.1844. Okay. And do we have to write a sentence? So the sentence for this one, I would just say, instead of what is the probability, I would just say the probability exactly 7 of the residents believe that taxes should be raised for road repairs is 0.1844. So basically you just take the question and make it a statement. This did not specifically say to write sentences, but generally that's a good idea. So the next one said, what is the probability that fewer than 6 of the residents believe that taxes should be raised for road repairs? So for that one, we have to again realize it says fewer than 6. So that means the probability X is less than 6. So that really means X would be 0, 1, 2, 3, 4, or 5. So that would be a binom CDF, but we would do 20 for my trials, 0.35 for my probability, but I would only go up to 5 because it's less than 6. So it's not including the 6. So I would do second vars and I would go all the way down to binom CDF. And I would put in my 20 for my trials, my 0.35, and then my 5. And again, you only go to 5 because it says fewer than 6. And I get the 0.2454 if I round it. So this would equal 0.2454. And I think, yeah, it did say go to 4 decimal places somewhere along the way. And again, the sentence would be, instead of what is the probability, I would say the probability that fewer than 6 of the residents believe that taxes should be raised for road repairs is the 0.247. So what you really could do is literally cut and paste. So I'll do that. So what we could do over here And you're going to see me literally cut and paste. And instead of saying what is, I'll just say this. I'm going to copy that, put it down here, and I'm going to start it out at the beginning of the sentence of the, and then just say is the 0.2454. So you can see I literally copied the sentence up there and pasted it, and just instead of starting it with what is, I just started it with the probability. Okay, and there would be my sentence. So then the next one says, what is the probability that at most 8? So I have to realize that at most 8 means less than or equal. So that'll be the probability x is less than or equal to 8. So here I am including the 8. So here really x here starts at 0, 1, and it goes all the way out to 8. So this one would be a binom CDF, and it would be the 20.35 comma 8. And I would actually go to the 8. I wouldn't stop short on that one because we actually want that one. So again, let's pull out the calculator. Where is my calculator? I think I just turned the calculator off, so we need to wait a second for it to come back. Okay, here we go. So for this one, we'll do second vars. We'll go down to binom CDF again. But this time around, we're still going to have the 20, the 0.35, but we're going to change this to an 8. And we'll get 0.7624. So the 0.7624. So again, if we want to get the sentence, we're literally going to cut and paste. So I won't say what is, I'll start with the, and I'll get rid of the question mark, and I'll literally copy it, go down here and paste it. I'll make it the capital, and then we'll just say is 0.7624. So that's really what you could do for the sentence. Makes your life a lot easier. You literally cut and paste, and that's completely what's expected. Okay, so let me give myself a little bit more room for the next couple. Okay, so what is the probability that at least 8 of the students or the residents believe the taxes? So for that one, we have to realize at least 8 would mean the probability that x is greater than or equal to 8. So that means you want x is 8, 9, all the way up to 20. So the easiest way to do that would be to do 1 minus the binom CDF, do the 20.35, but then we want case 8, so we get rid of cases 0 to 7. And that will work for us. So again, pull out the calculator. Let's do 1 minus second vars, and we'll go all the way down to binom. Oh, I passed it, binom CDF. And this time around, all the numbers stay the same, except the last one will go to a 7, because those are the cases we don't want. So whenever you're subtracting, you're getting rid of them. So that'd be 0.39897, so 0.3990. So let's go over here. So 0.3990 when we sort of estimate it to 3 decimal places. So again, if we need a sentence, what I would do is I would copy this. I'm literally copying and pasting, and then go down here and hit paste, and then we'll just say the probability of at least 8 residents believe that taxes should be raised for repairs is 0.3990 if I round it to my 3 places, or 4 places actually. Okay. And then the part F says, what is the probability that 5 or more? So 5 or more would be probability of x greater than or equal to 5. So that would be the same idea as the previous one. So it'll be 1 minus the binom CDF. It'd be the 20, the 0.35, and then we want case 5, so you'd put in a 4 there. So it's very similar to the previous one. It's just worded a little bit differently. Instead of saying at least, we're saying 5 or more, but it would be the same concept. It looks like I did the same thing with the calculator again. I somehow clicked it off. Did not mean to do that. There we go. So I guess I keep turning the calculator off on myself. Okay, so for this one, again, what I would do is 1 minus second vars, and I would go all the way down to the binom CDF and do the 20, the 0.35, but this time I want to get kid of cases 0 to 4, so that's why I'll put a 4 in there, and I get 0.8818. Okay, so again, if we wanted to write that as a sentence, I'm literally going to copy and paste here. I'm going to say we'll start with the, and copy. Okay. I didn't mean to do that. Ooh. Okay. We would just say the probability, I guess it went to the next page, the probability of 5 or more of the residents believe that tax should be raised for repairs is 0.8818, which is up in the previous question, the previous page, I guess we could say. Okay. So that would be that one. And then the next one would be find the mean and standard deviation of the number of residents of 500. So for this one, it would be the same idea as what we did in the very beginning of this question, but your mu would be n times p, but it would be 500 times 0.35. So if we do 500, it'd be 175. So the idea is find the mean and standard deviation. So your standard deviation would also be the square root of NP1 minus P. So that'd be the square root of 500.35, 1 minus 0.35. So if we do that calculation, and we get 10.66, 665, so 10.67. And it says interpret that values in a sentence. So all I would really say about that one is most likely in samples of 500, we would expect 175 to believe taxes should be raised for road repairs with a standard deviation of 10.67. Okay. And that would be that. And then would it be unusual to choose a sample of 500 and find 135 of them believe taxes should be raised for road repairs? So what I would do for that one is kind of what we did earlier, and just do the mu plus or minus 2 sigma, which would be the 175 plus or minus 2 times 10.67, and see what you get. So 175 minus 2 times 10.67, we'll get a lower bound of 153.66, and then change it to a positive in the middle. And I would get 194. So between 153.6 so that gives us an interval of 153.66, I believe. Let's just double check it. 66 to 196.34. and we want to know if 135 is unusual. So what we could say is over here. Yes, 135 of the residents believing raising taxes for road repairs is unusual because we expect between 153.66 to 196.34. So the 135 is not in our interval. Okay, so that would be that one. And then the last couple are expected value ones. So let's do those. So for this one, I would do the table like we have it here. I'm going to give myself a little bit more room to make it a little bit easier. So what I would do for this one is it says if an insurance company is willing to let a 25-year-old male buy a $500,000 insurance policy for $650, assuming the probability of the 25-year-old male of living the year is 0.999950, what is the expected value or gain for the 25-year-old male who buys the policy? What does this mean in terms of the long run? So this one is in terms of the male. So what's going to happen is, and you can do it two ways. This will be live, the male, he's going to live or he's going to die. The probability he lives, that's given as the 0.999950. So the probability he dies would just be 1 minus that. So we'll do that in a second. Now, as far as him living, he's going to pay the $650. And as far as he's dying, the insurance company will reimburse the family the $500,000, but minus the $650. So we have a little calculation to do here. So what I would do is let's do the 500,000 minus the 650. And we're going to end up with 499,350. And then if we do the probability, we'll do 1 minus 0.99995. Yeah, 4 nines and then a 5. And we get 5e to the minus 5, but that would be 0.4 zeros and then a 5, because we get 5e to the minus 5. So that means you have to put the 4 zeros in front of the 5 in scientific notation. So then technically what we could do is we can make this L1 and this L2, or we can just multiply across and then add. I'll just do it the old school way. But you could do the one var stats on L1 and L2. So I'm going to scroll down just a little bit here so we can see it. So do 650 times the probability of living. And I get 649.9675. Oh, wait, one thing I did forget. And I'll fix that in just a second. So when you're doing it from the perspective of the male, the negative goes with the 650. If you're doing it from the perspective of the insurance company, the negative goes with the 499. This one says in terms of the male, so we'll go that route. But I think most of your homework doesn't from the perspective of the insurance company. So the negative would go with them because one of them's losing the money. Okay, so I did forget that part. And so then we'll do the 499,350. and times the probability of dying. And that one would be the 24,965. So technically the 649 should be a negative number because we're doing it from the perspective of the man. So then you just take the two and you add them up. So the first one's negative, the second one is positive. And so we get negative 625. And that, let me fix my, so then the question becomes, what is our sentence here? So what we could write about this one is that let me get back up there. So on average, in the long run, year-old males who buy this policy will be out or lose, we'll say, will lose $625 per such policy. So the key is it says on average in the long run. You could also say, so the insurance company will gain the 625 per policy. You want to look at it from that perspective, because the 25-year-old male will lose it, but the insurance company will gain it. Okay. And the final one, similar problem, but this one's a little bit different in the perspective that I'm gonna make these a little bit bigger so I can write a little bit better. It's got just more spaces for win and lose. So I'm just gonna make these a little bit bigger. And again, just so you know, you could have done the one var stats on the previous one with L1 and L2. So for this one, the only thing we have to be conscious of is the probabilities were already there. So all we have to do is essentially copy this column. So this would be the 1 out of 1,000. So all of those probabilities, they're all like literally we can copy and paste those. So this one here will be 1 divided by 1,000. This one here will be the 10 divided by 1,000. And I did them in those orders. So this will be 100 divided by 1,000. Some of these simplify, but I chose not to do that. So you could see they're all out of 1,000. 500 divided by 1,000. So that would all stay the same. And then 389 divided by 1,000. So that column stays the same. But then over here, the dollar amount, you have to think of it as 6,000 minus the $70 for the ticket. And so you're going to get the 5,000. The $5,930 for that one. And then for this one, it would be the $3,000 minus the $70 for the ticket, because you don't basically win your money back. So that would be the $2,930. And then the next one would be the 2,000 minus the 70. So that would be $1,930. And then if you win this one, it would be 200 minus the 70. So that would be the $130. And then for the last one, if you lose, you're just going to lose your 70. So the easiest way to maybe do this one, we can multiply across, but we could also just put this column, this will be your L1, and this one will be your L2. So I could have done the previous one the same way, but let's do this one this way because it's a little bit longer. So literally what I would do is do stats, go to edit, and the first column will end up just being, and you can do the math here too. You could do the 6,000 if you didn't want to do it in your head, minus the 70. And that way, you know, you can just double check that you won't have any mistakes. So 3,000 minus the 70. So you can actually do the calculation right here. And you can see that I believe I did actually do the math correctly in my head. And then the 200. And then the last one will be minus 70. Okay, because we're losing the money. So there's always going to be a negative. It's just a matter of where is it. And then for this one, I can literally type in, you know, 1 divided by 1,000, and it will go through and just do the math for me. It'll actually do the division. So we'll just let it do that. I think, oh, this one should be 100. There is a mistake there. That one should just be 100. Yeah, I have extra zeros. That should be 100 divided by 1,000. I knew something didn't look right there, so I'll fix that. And then the last one should be 500 divided by 1,000, I believe. And then the very last one should be 389 divided by 1,000. Oh, not plus, divided by. So we have extra zeros in there, so that's not helping. We'll have to fix that. Did I do that right? The last one should be 389 divided by 1,000. There we go. There we go. So then what we should do is go stats, go over to calc, and do the 1var stats on L1 and L2 again, assuming I put the numbers in correctly. And you'll notice n should add up to 1, and then your average is 266. So if you do this correctly, and again, we do have a typo in here. Oh, actually, my typo is on the top. Up here it's correct, down here it wasn't. So if we do the 1var stats, 1var stats again, L1 comma L2, then your X bar will be your mean, which it always is, but you'll notice we got our 266. So, and that was your 266. So explain what this means. So just so we can put up here, this will be L1, this will be L2. So then it says, explain what this means in the long term of making this bet and why should you buy the ticket? So basically what it means is you're going to make money. So I don't want that. Okay, let's go over here. Oh, I'll do the pen. Okay. So basically, on average, in the long run, you can expect to make 266 on each $70 ticket. So it's on average. So it's not like you're going to make that each ticket. It's just that if you buy enough tickets on average, you'll end up walking away with winning about $266 for each ticket you buy. Okay. And that would be the chapter 6 review. So I will save all this and put it in your Canvas account.